Hello students, I am Brajendra Kumar Patel, PGT Chemistry, JNV Golaghat, Assam. Today I am here with the topic Semiconductors for class 12 first unit solid state. So let's start semiconductors. Students, on the basis of electrical conductivity, it means the substance which can conduct electricity and the substance which cannot conduct electricity. So we have to classify them. So on the basis of their electrical conductivity, we can classify the substances or the solids into three categories. Number one, conductor. Conductors are those solids which have conductivity range from 10 to power 4 to 10 to power 7 ohm inverse meter inverse are called conductors. It means if you pass current from these conductors via these conductors, then these conductors will show minimum resistivity. It means their conductivity is very high. So the measurement of conductivity, it is done in the terms of ohm inverse and meter inverse. So the conductivity of conductors, if it is ranging from 10 to power 4 to 10 to power 7 ohm inverse meter inverse, these are called conductors. A very good example of conductors, it is metal. You know, all the metals are good conductor of electricity. Second, insulator. These are the substances which have conductivity range from 10 to power minus 20 to 10 to power minus 10 ohm inverse meter inverse. It means their conductivity is very poor, or we can say they do not conduct electricity. And the third category, it is semiconductor. The conductivity range is between conductor and insulator. So the semiconductors, they have conductivity range from 10 to power minus 6 to 10 to power 4 ohm inverse meter inverse. Now these are the in terms of conductivity, but simply we can understand the conductors, insulators and semiconductors as conductors. These are very good, they conduct electricity in greater extent. Insulator, they do not conduct electricity. And semiconductors, so semiconductors, they are conductor, but their conductivity is less than metals or less than conductors. So these are three types of conductors. Next is semiconductors. So we will study semiconductors in detail. So let's start. Semiconductors, these are of two types. First, let me tell you which elements are classified as semiconductors. So in periodic table, you know the group 14 element except carbon. Carbon has atomic number 6 and the distribution of electrons, it is 2 4. It means in outermost orbit it has 4 electrons. So except carbon, the remaining elements like silicon and germanium, these are semiconductor. Carbon is insulator, silicon and germanium are semiconductor, and remaining two elements, they are very good conductor. So semiconductors can be classified into two categories. Number one, it is intrinsic semiconductors. Intrinsic semiconductors are those elements which are found in pure state, means they are pure element. For example, silicon atomic number 14, configuration 284. So silicon is intrinsic semiconductor because it is pure semiconductor. Second category is extrinsic semiconductor. So extrinsic semiconductors, these are the semiconductors which are prepared by mixing a foreign substance into intrinsic semiconductors. For example, if you take example of silicon, then if other element like boron, aluminium, gallium, it is mixed with silicon, then the semiconductor form will be called extrinsic semiconductor. So here there is a term which is known as doping. So what is doping? Doping is nothing else, just a process of adding impurities in intrinsic semiconductor, or simply we can say the process of mixing of other group elements into 14 group elements is called doping. So let's see extrinsic semiconductors. So extrinsic semiconductors, as I told you, that extrinsic semiconductors are prepared by mixing 13 group elements or 15 group elements or other group elements with 14 group elements. So these conductors can be classified into two types: p-type semiconductors and n-type semiconductors. So let's start p-type semiconductors and n-type semiconductors in detail. Before starting semiconductors, let's see the band theory of conductivity. Means this theory was given to explain why the semiconductors are called semiconductors. Their conductivity range, it is between conductors and insulators. So to explain the band theory of conductivity by semiconductors, we'll know some terms which are known as valence band, conduction band, and energy gap. Students, as you know, metals, they have half-filled orbitals. For example, lithium, atomic number 3, configuration 1s2, 2s1. It means it has one electron in second orbit. But as you know, the maximum capacity of second orbit, it is 8. Or if you see the configuration, it is 1s2, 2s1. It means in s orbital only one electron is present. It means it is half filled. So the atomic orbitals which are partially filled or full filled are called valence band. Okay, so you know, when atomic orbitals combine, they form molecular orbitals to form molecules, and these molecular orbitals are closer in energy. So the atomic orbitals which are partially filled or full filled are known as valence band. Conduction band, the orbitals which are empty are called conduction band. Let's take an example of lithium. Again, atomic configuration of lithium is 1s2, 2s1, 2p0. Remember, in second orbit, 2s it is half filled and 2p it is vacant. So 2s is valence band and 2p it is conduction band. Got it? Valence band means those orbitals which are partially filled or full filled, and the conduction band, these are vacant orbitals. And energy gap, so the gap between valence band and conduction band is known as energy gap. As you can see in this picture, here I am zooming this picture. Here you can see, in case of metal, it's a partially filled band. Okay, blue color, it is showing the partially filled orbital or complete filled orbital, and the vacant box, it is showing the conduction band. So here we have two bands, valence band blue colored and conduction band, it is empty. In second picture, overlapping band. Overlapping band means you take an example of boron, then you can beryllium, then you can see it has configuration 1s2, 2s2. Second orbital, it is fulfilled. In excited state, one electron excites into p orbital. So 2s it is overlapping with 2p. So the orbital 2s was fulfilled, and now in excited state it is merging with 2p. So partially filled orbital or fulfilled orbital, these are valence band which are shown by blue color, and the violet color band, it is overlapped area, and the vacant is conduction band. So the different distance between valence band and conduction band, it is known as energy gap. So now let's explain the conductivity on the basis of band theory. To conduct electricity, the electrons, they jump from valence band to conduction band by absorbing heat or by observing energy. So when electrons they jump from valence band to conduction band, they conduct electricity, and for the excitation of these electrons energy is required. So conductors, which are conductors? The elements which have a very small gap between conduction band and valence band. So electrons can easily jump from valence band to conduction band. So these are very good conductor. Then in terms of insulator, you can see in picture here, you can see in this picture that the gap between conduction band and valence band, it is very large. So electrons they are unable to jump from valence band to conduction band, thus they are unable to jump. It means they will not conduct electricity, so they are insulators. Now define semiconductors. So semiconductors are the elements in which the energy gap it is less than insulator but greater than conductor. So electrons can jump from valence band to conduction band, but not much electrons are able to jump. So their conductivity it is less than metals. So you remember this thing. In case of semiconductors, the energy gap is small, so electrons they can jump to from valence band to conduction band, but not much electrons. Okay, so this was the band theory. So again, quick revise on band theory. According to band theory, partially filled orbitals or full filled orbitals are known as valence band. The empty orbitals are called conduction band, and the distance between valence band and conduction band is energy gap. In case of metal, energy gap is very small, so electrons can jump from valence band to conduction band, thus they can conduct electricity very easily. So their conductivity is very high. In case of insulator, energy gap is very large, so electrons are unable to jump from valence band to conduction band. And in case of semiconductors, the energy gap is less than insulator but more than metals or conductors. So much electrons cannot jump from valence band to conduction band. Only few electrons can jump. And now the question is, how can we increase the conductivity of semiconductors? So to increase the conductivity of these semiconductors, we apply a process which is known as doping. Earlier I told you what is doping. Doping is a process of mixing of foreign substance with semiconductors. So on the basis of mixing of the elements, we can classify semiconductors into two categories: p-type semiconductors and n-type semiconductors. Let's see p-type semiconductors. So students, as you know, silicon it belongs to 14 group elements. It means its atomic number is 14. The configuration is 284. It means it has 4 electrons in its outermost orbit. So students, here in this picture you can see each silicon has 4 electrons. The blue colored dots they represent electrons of silicon. So you can see every silicon it has 4 electrons, and it is forming semiconductors by sharing 1 electron with 1 silicon each. So it has 4 electrons, so it will make 4 covalent bond with 4 different silicons. To make p-type semiconductors, we mix 13 group elements like boron or aluminium with 14 group elements. So here see in this picture you can see 13 group elements. These are boron and aluminium. So let's take an example of boron. Atomic number of boron is 5. Configuration is 2, 3. It means it has 3 electrons in outermost orbit. So now see, in center I am showing boron. So boron it is forming 4 bonds with silicon. Each silicon is sharing 1 electron, but boron has 3 electrons only. So the green colored electrons are of boron. So in boron, it needs 4 electrons to form 4 covalent bond with 4 different silicon atoms, but it has only 3 electrons, means this one is 1 electron deficient. So in place of this green electron or green dot, I am showing here hollow circle. This is called hole because here electrons should be present. In case of intrinsic semiconductor, in place of boron it was silicon. It means all 4 covalent bonds were satisfied, but here 1 electron is less. So this semiconductor is electron deficient semiconductor or p-type semiconductor. And now how it conducts electricity. So when you apply electricity in such semiconductors, the neighboring electron, you can see hole, its neighboring electron, you can see it. So this electron takes place in this hole, so again leaving its place empty. So the next electron takes its place. So simple, it's a shifting of electron. So as electrons shift in forward direction, the hole will move in backward direction. So here the conductivity, it is due to the movement of hole, and the direction of movement of hole is the direction of flow of electricity. It means if hole moves left side, means left side electrons are taking its place. So if hole moves left side, then electricity also will be conducted in left side. So the direction of movement of hole is the direction of electricity. This is p-type semiconductor. Now n-type semiconductors. So when 14 group elements are doped with 15 group elements, the n-type semiconductors are formed. Let's see how. So see here, I'm taking example of 15 group element, that is phosphorus. So phosphorus atomic number is 15, configuration 285. It means it has 5 electrons in its outermost orbit. So out of 5 electrons, 4 electrons are used to form 4 covalent bonds with 4 different silicon atoms, and 1 electron is left. Okay, this electron is responsible to conduct electricity. You can see the free electron. This electron is conducting electricity. So this is called n-type semiconductor. And the direction of movement of electron means if electron moves left side, so remember the direction of electricity and the direction of electron, it is just opposite. If electron moves left side, electricity will move in right side. So the direction of flow of electron is opposite to the direction of flow of electricity. So n-type semiconductor, it is formed by mixing 15 group elements or electron rich element with 14 group element. Again one more term, these p-type semiconductors and n-type semiconductors are also known as p-type semiconductor. It is known as electron deficient conductor because it has 1 electron less as compared to intrinsic semiconductor or pure silicon. So the p-type semiconductor is electron deficient semiconductor, and n-type semiconductor, it is electron rich semiconductor. Why it is electron rich? Because it has 1 extra electron which is conducting electricity. So students, these are semiconductors. Where these semiconductors are used? So these semiconductors are used to make electronic items like, okay, so this was the semiconductors and the band theory of conductivity. Students, in next chapter we will discuss about magnetic properties of elements or different magnetic behavior of solids. Thank you very much. Like and subscribe. Thank you.